Very quickly before we start this video, I want to say a very special thanks to Vufine for replacing my display free of charge when I accidentally broke it, and to Steve, my mom's boss, for providing the helmet for me to use. Thank you so much, both of you.
Gauge heads-up display.
Check.
4-door preferences from home interface. Ready? 10, 3, 2, 1.
Yeah, I can do that. Over the past year or so, I've been working on my own version of the Hacksmith's Ironman helmet. Now, I really liked their Ironman helmet, so I've while I was in quarantine over the past, 14 months now, I've been just slowly working away at making my own version. Now, my helmet has shifted from a direct clone, where I still have used all of their components, but it has shifted more from a direct clone, quote-unquote, of their helmet to what I was hoping to use as a motorcycle helmet with object detection, and now its own standalone thing where I can control my laptop's mouse from the helmet. Now, you may be wondering to yourself, Jared, why did it take you so long to build this helmet? 14 months is a long time to put in one feature of mouse movement, right? I would agree. Problem is, well, last summer when I first thought of this idea, I was up at a park doing park things. And while I had a great time, and as you can see from the views that I took, it was a beautiful place to work. However, it also meant that I had no Wi-Fi, no internet at all. Just like, I was just sitting up there in the middle of the wilderness, just kind of vibing. And while that was fun, didn't help for research. Fast forward to when I got home, and what was I gonna say? Fast forward to when I got home, and school became a thing, and third year engineering courses are always just so much fun. They give you so much time to do research and development and prototyping that it's taken me about a year to get this project up off the ground, but I'm very, very, very happy with how it's turned out so far, and I'm excited for what's coming in the future. Now that I've given you a little bit of background on why and how the development's gone, let me show you the actual helmet. So here's the helmet in all its glory. You have the display right there, which just fits right above your eye. You have the Raspberry Pi's camera with the blue light filter lens on it, and then the Raspberry Pi sits up top inside here. I would show that, but it doesn't fit incredibly well because this is only a prototype, and I just need it to sit properly. But you then have the Ethernet cable coming out the back, you've got the HDMI from the display, and you've got a power cable for the Raspberry Pi. Now that you've actually seen the helmet, let me show you what it's like when it's actually running. Completely inconspicuous, right? Well, let's see now what it looks like from inside the helmet. Yeah, so the helmet doesn't work as great as I had hoped. However, let me show you a video I created earlier to showcase the technology and my hope. And then afterwards, I'll explain everything. So what you're seeing here is a pre-recorded video that I took with my phone and then passed through the Ironman Helmet's object detection model. As you can see, it's much more accurate than what the actual helmet does, and it actually does move the mouse pointer to the top corner of the box that it detects the finger in. I will explain why this is and how I plan to fix it next. Okay, now that I've showed you how it works and what it does, let me explain some of the troubleshooting and takeaways that I had to go through to get this project even to the point where it is now. So firstly, there was the problem of the no IR filtered camera. So when I had first bought all of the parts for this project, I was basing mine purely off of the Hacksmith's video, and I wanted to use the no IR camera for better low light vision. That's wonderful and it's great and it works well for its for that application. The problem arises when you try and do anything that relies on a model. So with the object detection, it relies on multiple pictures of an object to then train the computer to see the object. However, when you have a no IR camera, everything looks a bit more red because there's no infrared filter. This then makes it very difficult for the camera to even detect the hand, the finger, the object, whatever you're training in the frame. That's why we saw better performance when I used my phone's camera, which is what I'm taping all of this on right now, versus the Pi's helmet. Secondly, there's the problem of performance. So right now, my laptop and the Raspberry Pi are both underpowered in a sense. The Raspberry Pi works really wonderfully, but there's only really so much performance you can get out of something this size, right? Besides that, even with the laptop, my laptop was made a few years back before all of the Google's TensorFlow and NVIDIA's partnership with it really, I guess, came into effect or was substantiated. And the problem there is my laptop's graphics processor isn't powerful enough and it doesn't have all the right technologies to process the object detection quickly. So you run into issues there with performance where even though the laptop is much faster than this Raspberry Pi, it still runs into performance issues with the camera. Biggest issue I ran into, however, was the actual TensorFlow software itself. All of the tutorials that I used and followed online were written for TensorFlow 1.x, whereas now the industry has changed to using 2.x. And while most of the code is able to be reused and recycled, there's a lot of little things that changed in between the 1.x and 2.x versions of the software that just aren't compatible. So I had to spend a long time trying to iron out all the little issues with both. Now that we talked about a few of the issues that I've had with the technology, let me leave you with a few positive takeaways as we end this video. Firstly, what can this technology do, Jared? What's the practical use of it? Literally anything. I'm hoping if I can get a more precise model, if I can build a more precise model for this camera and get all of the code worked out, then I can build basically my own VR setup using a whole bunch of cameras and the object detection. Or, in another sense, I've seen people use it to detect cards or math or traffic lights, or even my own personal one of wanting to use it for a motorcycle helmet. The possibilities are pretty much endless when it comes to figuring out what we can use computer vision to detect. So I'm really excited to continue working on this project, though I'm going to put it on the sidelines for a couple of months now. I'm really excited to continue working in this field and developing the software and the models that do more in a more precise and quick manner. And on that note, I'm going to end the video here. Thank you so much for watching, and yeah, check back again if you want to see, because I plan to post more projects and really cool things that I've been up to on this channel. So thank you so much. Take care, guys.